The PTS is the performance test specification which has been published by the solid-state storage technical working group. It's a specification for the comparative test of solid-state storage. Solid-state storage performance depends on the environment, on the stimulus, on a variety of factors, in addition to the test methodology. The PTS allows users to test SSDs the same way and to have an apples-to-apples comparison. The PTS is important because when you test SSDs, depending on how you test them, you can get different test results. So those that want to integrate or design around SSDs need to know what the predictive behavior of the SSD will be. By using the PTS, it's a standardized methodology. It takes the SSD to what we call steady state, which is a repeatable performance range from where you can take test measurements. And it also defines a reference test platform, which is a recommended hardware-software environment to normalize the test environment so that comparisons can be compared to each other. I mean, you can look at end users who just want to know what kind of SSD I might need to buy for my application or how much performance I might need to get. For IT or enterprise users, the SSDs are good to use when you're trying to develop a tiering strategy or you're trying to optimize your hardware-software stack to your storage. To firmware developers and SSD OEMs, it's very important because you need to validate the performance and design of your SSD. So the PTS provides a four-corner framework to do standard benchmark tests, but there are additional tests that vary different test settings to emulate different application environments. So we're seeing more tests that are looking at the response time and latencies of SSDs and testing the drive at different levels in the software stack. The most recent testing is involved using real-world workload captures, which is a way to capture an application workload at various levels in the software stack and to look at the I/O composition of those workloads. It's all about the workloads. You can see SSDs of different interfaces, form factors, and protocols all claiming very fast numbers, hero numbers, steady state numbers, FOB, but it really depends on what your application workload is. There's much more testing going on to capture what these workloads are, but there's a lot of work to be done to understand what it means. So I think everything's going to come down to the workload because advanced abstractions at every software layer, whether it be deduplication or compression or encryption, packetization, tiering, or whatever you're doing in the software stack, is going to affect that I/O stream from application space as it goes to the drive. So with each layer of abstraction changing the I/O stream, you very rarely know what is getting to the drive. And if you don't know what's getting to the drive, you don't know how that drive is going to perform, and you won't know how to optimize your system to get the best performance you can. There are several ways you can capture workloads. There are public and private tools available. The SNIA SSSI has been advancing a workload I/O capture program with a really funny acronym we call WIOCAP. WIOCAP uses capture tools from a company called Hyper.io, which is the foundation of the IOTA twig. There are new tools out that are public, such as dtrace, perfmon, and others, which allow end users or drive developers to do their own captures. What these captures do is they capture and characterize the I/O streams that a workload is doing at various levels in the I/O stack. There are a lot of ways to use these captures, but the most important thing is first to do the captures, then to look at the data, and then to test drives to those captures. The underlying test methodologies for the PTS, while based on NAND flash SSDs and based on the notion of steady state, they are still applicable to other classes of storage. The PTS is based on block I/O measurement, but you can also apply the same test at the file system, or you can apply them to memory. In the memory space, it can be byte addressable, it can be by file system, and there's already been tests using the PTS to measure block I/O activity on NVDIMM type ends. Why is this important? It extends the common base of comparative results from different storage classes, from hard drives through hybrid drives to SATA, SAS, PCIe, U.2, M.2, and now NVDIMM-N. Future extensions of the PTS can shift from block testing to byte testing or to load store. These are all similar applications that use different tools in the software stack. Persistent memory is on the horizon, as are a lot of other new storage technologies. MRAM, there's Crosspoint, there's storage class memory. These are all can be called subsets of persistent memory, but I think each one has its place. The business and market adoption criteria around them depend on availability and price, but we see a lot of activity in these areas. And once you remember that while it's very sexy to go after the fastest, newest technology, if you really look at what's shipped out there and the timeline, good old SATA drives will be around for a while. We're going to see a lot of activity in M.2 as it applies to both the client and enterprise. And with the accelerated speed of PCIe Gen 3, you're going to see a lot of work being done in the software stack to optimize the software to the high-speed flash. So whatever the flash is, the game is all about optimization. And in order to have successful optimization, it's all about the workload. So go out and test your workload, find out what's really going on, and get that information back to the developers and the integrators.